All right, very good. 37. So, right, there are minimum and maximum values. You can have a maximum of 20 and 40, 60, or you can have a minimum of 40 minus 20, where they're in opposite directions, which would be 20. So, between 20 and 60, the only value that we have is 37. You can have them in the same direction. Can't see that. The same direction. That would be 60 units long. Or you can have them in opposite directions. That would be 20 units long. Somewhere between 20 and 60. It's a good middle school joke. You want to hear it? Knock, knock. Smell mop. No thanks. Okay. Let's look at some other questions. Let's look. Have we worked all the ones in the back? I'm not sure if we have. Let's just take a look. Oh, let's try number 27 here. It's sort of like that 45-degree one, but it's a little bit different. Number 27 on exam 1 has a positive x component and a negative y component. The y component is bigger than the x component. Which of these is a possible angle? When you're looking at these, you want to first figure out what quadrant is it in, and then that might be good enough to find the answer. So I don't think it is in this case. Put in your answer now. All right, doing well. I'm going to stop at 50. Very good. E is right. So it's kind of a tricky problem because, first of all, I have a positive x component. So my x component will be over here somewhere. And then I have a y component that's bigger than the x component, and then it's negative. So my y component, I'll exaggerate it, will be like that. And so my resultant will look like this. Now that gives me in the fourth quadrant. So that can either be A, not that one, or that one, or E. It can be either A or E. And the way I want to tell which is it, A or E, is because the y component is bigger, I am south of this 45-degree mark. So I'm closer to the 270 than I am to the 360. So the 290 is the only possible answer. 350, for 350 degrees, the x component would have to be bigger than the y component. But that's not what it says. The y component is bigger than the x component. You can see something like that on the test as well. Let's just try this one right quick. I think we've done one very similar to it, but let's try 26. And you'll definitely have one like that. I'll have two arrows, and you'll have to find the sum or the difference. right, let's stop at 52. 52. I think that's right. Yeah, C is right. All right, so I have B minus A. So I draw B first, and then I draw negative A. Negative A, I just flip the direction of the vector, and then the resultant will look like this. This is A, or excuse me, this is B, negative A. This is B minus A, so that's going to be C is the right answer. You'll have to do one of those, okay? You should get that one right. I want everybody to get that one right. All right, so listen, I'm not going to do that example in the comic strip example. It's just like what we've done before. But instead, let's look back at this old exam, and then we'll look at some others, and just sort of have a mini review session here, okay? Just to help you jog your memory as to what's going to be on this exam. You will have approximation. I think there was one or maybe two questions on approximation where you have some item either in front of you or that's very familiar to you, and I ask you to estimate the area, the length, or the volume, or maybe the mass of that object. You need to know centimeters, about your pinky. You need to know meters, about 3 feet. You need to know kilograms, a little over 2 pounds. Okay? You'll also need to know how to convert your units in the course of that. So some estimation type problems. You'll have one or two of those. You're going to have dimensional analysis problems like number 3. You're going to have a couple of those. And we can look at that. Number 4 as well. You'll have one significant figure problem. You'll have one standard of measurement problem. You just need to know the standards, what they are, what allows for a good standard. You'll have 2 trig problems. I think you have 1 units problem where you're changing units from one system to another. If you have conversions between systems outside of the metric system, I'll give you the unit conversion factor, like miles to meters, for example. I'll tell you how many meters are in a mile. But you need to know your metric prefixes. You know, those metric prefixes I gave you. You'll definitely need to know those for the test. You're going to have a couple, 2 or 3 kinematics problems. Hey, look back at that homework assignment, because I did pull some questions from it for the kinematics problem. Okay? Make sure you look at that. That's a good resource for you, and you should have the answers and even a solution available on OpenStax. But if you're having trouble, you know, I'm here, so come see me. So several 3 to 4 kinematics problems. You're going to have a lot of graphing problems. I don't know, 6, 7, maybe even 8 graphing problems. That'll be either qualitative or quantitative. So stuff like this, well, that's let's see, like number 18, like number 17. We can look at some of these in just a moment. You'll have some conceptual problems like number 14 through 16 that are similar to what you saw in the concept test. Conceptual problems about kinematics. You'll have graphing problems. I call these quantitative graphing problems because you're actually dealing with numbers. You're not just describing in words the motion. So you'll have a graph like this. I'll have some points on it, and I'll say, what is the instantaneous velocity? Or what is the instantaneous acceleration? Or what is the average velocity or acceleration? You'll have to do both of those on the test. You'll probably have some physical scenarios where I ask you to pick out the graph, or I'll give you a graph and ask you to describe the physical scenario that fits that graph, kind of like number 21. You're going to have to find the distance that an object travels. If I have v versus t, how do I find distance? I find the area, right? And you're going to have vectors. I guess that's it. Yeah, and you have 3 vector questions. All right? What do you feel like is your weakest area? I can go through and I'll just pick some questions that we can look at on other exams. But if there's something in particular that one or more of you want to look at, we can do that now. Graphing. Okay. Let's look at qualitative and quantitative, okay? Because you're going to have a lot of those. And since we've done a lot of these, I'm going to look at another old exam. So if you go on the website, and hey, by the way, let me show you also that the homework, this is I don't want to call it homework because we don't want to mix it up with our OpenStax, but the extra practice problems that are in your workbook, the solutions to those are here on the website too. So if you're working through those and you just get stuck, that's a good place to go. And the concept tests are here. You can download them. I don't think I've posted 3A yet, but I will soon. Old exams. You all have fall 15, right, in your book? Is that right? All right, let's look at fall 16 then. All right, so let's look at number 19 right here. This is fall 16, exam number 19, exam number 1. And I have this graph, and what I want you to do is to find the velocity versus time graph that best represents this. All right. We're not going to do it as a clicker question, okay? I'll just sort of go through and I'll show you how to do these. So whenever you're looking at position versus time graph, remember the slope of that position versus time graph gives the sorry, I can't write on this. The slope of the position versus time graph gives the what? The velocity. It gives the velocity. All right, so I want to look at the slope of this graph. Is it positive or negative there? Positive. And it's still positive up here as well. Is it big or small at first? It's big. So it's big and positive, and it's small and positive. So because it's positive, I can get rid of this one and this one, because those both represent negative velocities. And I'm going from big to small. So that's going to be C, going from big to small. Does this object have, we said it has positive velocity. Does it have positive or negative acceleration? Now when I'm asked that question, what I want to ask myself is, what is the direction of the velocity, and is it slowing down or speeding up? If it's slowing down, the acceleration is opposite the velocity. If it's speeding up, it's the same direction as the velocity. So what is this one doing? Is it slowing down or speeding up? It's slowing down. So is the acceleration opposite the velocity or in the same direction as the velocity? Opposite. So the acceleration then is what? Negative, right? It's opposite this. Right? So this has a negative acceleration. Why don't you do one? We'll give you another one. How about this one? X versus t. Does this one have positive or negative acceleration? Just think about it for a moment, and I'll ask you to commit to an answer. Does it have positive or negative acceleration? Well, is the velocity positive or negative? Is it slowing down or speeding up? Positive or negative acceleration? Let's see, I think that's right. I always have to think it through. So I have negative velocity. It's slowing. So I have positive acceleration. So this is an example when I have something that's slowing down that's actually has a positive acceleration. All right, let's look at some of these quantitative things. Oh, let's look at this one. Number 20 is interesting. So consider this graph. Which of these describe the motion of the object for the 3 time periods? The object in section A, right here where it's a straight line, it says the object is traveling at a constant speed. Maybe. It's actually not moving at all, right? So we'll go to the next one. The object has a negative acceleration. Positive velocity, speeding up, positive acceleration. And so that's not right. The object is not moving. That's correct. The object has an increasing speed in the positive direction. That's correct too. The object is traveling at a constant positive speed in C. Is that correct? Yes. So in this one, B would be correct. So be able to describe these graphs in that way, what the motion is doing, and be able to go back and forth between position and velocity diagrams. let's look at, okay, so this looks like it was an OpenStax question. I think I did on this graph actually for an OpenStax question. So here I want to know the average acceleration for the runner between t equals 2 and 8 seconds. Now remember, anytime you see that average, you want to think delta, in this case, delta v over delta t. A is equal to delta v over delta t. What I like to do is I like to pick the points. There's my t equal 2 seconds. There's my t equal 8 seconds. And I draw a line between them. Some of you like to just pull the numbers off the graph, and that's okay too. But I like to do this, and then I find the slope of that line that I drew. In this case, my run is 6. My rise goes from 6 to 12, so that's also 6. And so the answer would be E, 1 meter per second squared. Or you could just look at the numbers, delta V over delta T. That's going to be 12 minus 6. Delta T is going to be 8 minus 2. Okay back there? Alright, so that's going to be 1 meter per second squared. Alrighty? You'll have to do something like that. You could also have a problem where it's not a linear graph. Let's see if I have one here. I don't think that oh yeah, here we go. What is the velocity of this object at t equals 7 seconds? I think this is an OpenStax too. For that class. I don't think y'all have this one. I want to know the velocity at t equals 7 seconds. Now in these cases you want to draw a tangent line. So at this point the tangent line is pretty easy because the function is pretty straight at this point. I just draw a line that looks like that, and then I find the slope of that line. I'm going to go from here, and that's going to be about 10 over 5. I guess that's not right. Let's see. That's about 3 to 10, 7, 3 to 17, about 14. I keep getting -2. I think the answer was D. I forget. But anyway, you find the slope. $17.5 and 2.5. Oh yeah, I see what you're saying. Oh, okay. 17 minus 3. So 17 minus 3, and what do I have here? 5? Okay. And then that gives you, what is that, 1.4? Yeah, so the slope of that would be 1.4. I'll have answers that are separate enough that you'll be able to find it. Okay? So you'll have a bunch of problems like that. What else? You want to look at some kinematics problems? I think that people often struggle with those. Kinematics? We're not getting out early. Like, I'll find something to do. Kinematics? Want to do some kinematics? Yes. The answer is yes. Okay. You will have a freefall problem. So you'll have one where you throw something up and it comes back down and you have to tell me something. Or you drop something and you have to tell me something about that motion. So, for example, here, number 11, you throw a ball up with an initial speed of 50 meters per second. How long does it take for the ball to return to your hand? So we've worked through several of these, but I have an object. It goes up and comes back down. And I want to know several things about this. Well, in this problem, I want to know just how much time. What is the total time elapsed? There's some special things that I know. First, I know that the time at the top equals, the velocity at the top is equal to 0. And then I also know that the time up is equal to the time down. It's important that you master this problem, especially because we'll be using it in Chapter 3 when we do projectile motion. And so if you know how to do this problem inside and out, then you'll do pretty well on Chapter 3's projectile motion, which can be difficult for students. But if you got this problem, we're just going to add one little complication. So what we do is we say that v is equal to v naught plus at. V naught here is given 50 meters per second, and v is 0. So I have 0 equals 50 meters per second plus negative 10 times t. Be careful, guys, because our acceleration in the y direction is always minus 10. But if you have something that's moving in the x direction, it's not necessarily 10 or minus 10. It's just whatever it is. All right, so that's only when you have objects in free fall. Solving this for t, I get t equal 5 seconds. So what would the answer be here? It's going to be 10 seconds, right? It takes a total of 10 seconds. I could also ask you to find the total height that the ball goes to, and how would I do that? If I want to know the height to which this ball rises, I know this distance, y, I would say v naught times t plus 1/2 a t squared. And so that's going to be 50 meters per second. Do I use 10 seconds or 5 seconds? I use 5 seconds, right. You have a couple of times floating around, but since I want to know the position at the top, I use the time at the top, and the time at the top is 5 seconds. Plus 1/2 times 10, minus 10 times 5 squared. And so that's 250 minus 125, 125 meters. You need to know how to do those for sure. You will have a problem that'll look something similar to that, where I ask you the time, or I ask you the height to which it travels. I might ask you the total time, or I might just ask you the time that it gets up to the top. But be able to know how to answer all those questions. We'll have that. I'm going to try number 12 here. You had some problems similar to this in the open stacks. It says in a snapshot, a hockey player accelerates the puck from a velocity of 5 to 30 meters per second. Can you guys in the back see this at all? You can see it? Seriously? I couldn't see it. I'm going to make it bigger. The hockey player accelerates the puck from a velocity of 5 to 30 in the same direction. If this shot takes 0.02 seconds, calculate the distance. Whenever you have a problem like this, you first start just by writing down everything you know. If it helps you draw a picture, that often helps me to draw a picture. I don't think you really need to in this case. But we write down everything that we know. I know that it goes from 5 to 30 meters per second. So V naught equals 5. V final equals 30. I know that the time that it takes is 0.02 seconds. Just move my decimal place over two spots. And that's all that I know. But I want to know what is x. And so since I'm looking for x, I know that I'm going to be using this. V naught t plus 1/2 at squared. I got t. I got v naught. Oh, but look, I'm missing a. And so you want to think about, well, how can I find the acceleration? And so let's write down our other kinematics equation. V equals v naught plus at. I know v, I know v naught, I know t. So look, I can solve for a. V minus v naught, that's 20 minus 30 minus 5. $12.50. So that's my acceleration, and then you can come in here and solve for what is x. You have some very similar problems on OpenStax in your kinematics, the homework assignment that you had on kinematics. I would go back and review those because you'll probably see one. So that is x is equal to 5 times 0.02 plus 1/2 1250 0.02 squared. Might know the answer to that? 0.3. Okay? Be prepared to do a problem similar difficulty, similar layout, but different, of course. They're all a little bit different. And so, what do you need in order to master those? Practice, practice, practice. Practice is also helpful because when you go into the test, like some of you are just going to freeze up and you don't feel like you're properly prepared. But if you practice a lot, it'll prevent you from freezing up. I mean, some of you are going to freeze because it's going to be cold in the auditorium and you didn't bring a jacket. But like some of you are just going to sort of, I don't know how to do this. But you do know how to do it. You need to sort of relax and be prepared. Being prepared will help you a lot. Okay? All right. What else, people? What's a weak point for you? Dimensional analysis, trigonometry, sig figs. Dimensional analysis? I think that's what everybody said. Yes, let's look at dimensional analysis. It seems like it should be easy, doesn't it? It seems like it should be easy. And, you know, it's not that hard, but it's not trivial either. So in these, you want to look at the equations, and then when you can, simplify them. Tell me if you can in these. And then put in the units for each individual variable. So for example here, starting with number 1, I would have meters per second on this side, and then the square root of AX. So that's going to be the square root of meters per second squared times meters. So this is going to be meters per second on this side and meters per second on this side. Because this becomes meters squared per second squared, and then the square root of that is meters per second. So this one is okay. Oh look, I could just stop right there. Or it could be either B or E at this point. So I'll have to check the others. For number 2, X is meters. AT squared, that's meters per second squared. T is seconds squared. So far we're okay. Yeah, Gavin? M squared over, you would have, I think what you're asking is this would come out to be the square root of M squared over S squared, right? But when you square root that, it becomes meters per second. Yeah. We haven't done that particular type of problem before, but you should be prepared to do stuff like this. Let's see, where was I? So far we're okay on number 2, and then plus VT meters per second times seconds cancels, 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 cancels. Check, check, check. So number 2 is okay. So that means E is going to be the right answer. All right, because 2 is also okay. But let's just show it with 3. That I have meters. Just forget about the 2 and the 3. That doesn't mean anything. Meters per second, seconds. I cancel, so we're okay so far. Minus meters. Meters squared per second squared. That's my V squared. When I have stuff in the denominator, like an acceleration, I flip it and bring it up. So I get second squared per meter. And then 1 over meters. So notice this whole term right here, over, this all represents just this B squared over AX. I like to write it in fractional form like that. And let's see, that cancels there, and that cancels, so we're all okay. So as we expected, 3 is also correct. Look at your options in multiple choice exams. That's a good practice anyway for you MCATers and other folks, that when you're taking a multiple choice exam that you look at all the options, because often some of them are not going to make any sense at all, and you can just get rid of those. All right. Y'all got trig, right? Okay with the SOHCAHTOA and the quadratic? I think we're probably okay on that. This one is a little bit different where you have to find the units. We've done one of these before. Let me just show you. In fact, let me show you. This is probably a simpler way for you to think about it. I have x over a equals q over v squared. I'm just going to solve this for q. I want to know the units of q. If I solve it for q, that's x v squared over a. And whatever the units of this side will equal the units of Q. And so that's going to be meters, meters squared per second squared, and seconds squared over meters. That's our acceleration flipped. So it's going to be meters squared. Okay? You have two, I think, dimensional analysis problems. Okay, people? What else? Anything else that's nagging you? Take a moment. You can look back at your other old exam on your 2015 exam. Or any other material that we should cover? Take a moment to think about it. Yeah, Bree? Now, you will not have to use the quadratic formula. So if you think that you have to use it, you're wrong. You will not have to use it. I know you have to use it on, I think, what you're one of your open stats assignments, but not on this test. So looking at fall 2014, question 21. I know you are itching to go. We'll go soon. But it's good to see these things. 21, Crystal? Okay, so whenever you approach a problem like this, you want to start just by writing down everything that we know. So I know that t is equal to 10 seconds, that it covers a distance equal to 100 meters, and I also know that v final is equal to 0. And then I like to write what I don't know. Well, I don't know v naught, but that's something that I want to know. And I also don't know its acceleration. All right? And so then I go from there. I like to write my equations down just sort of off to the side. In fact, when you get your test, you're going to have a sheet of paper on the front of it that'll have where you bubble in the answers. You're going to tear off that sheet of paper, and there'll be a blank place there. You can write stuff, have notes and stuff. So you can just write those two equations. Just have those two, and maybe your SOHCAHTOA, just so you have it in front of you as you're working through the test. All right, so I need to know A. Let's see, here I have V. I don't know V. Oh no, I do know V. I don't know V naught. And I don't know A. Oh, okay, so what you had to do here, this was actually where you had to solve it. We had to substitute one equation into another. Let me show you quickly how to do that, but I'm not going to require you to do this kind of algebra on the test, okay? It just gets a little tricky. So you have 0 equals V naught plus AT. So V naught is equal to negative AT. Oh no, this isn't difficult. And I want to know, come over here, I can say that X is equal to negative AT times T. What I did there is I just said this and subbed it in up for V naught there. Plus 1/2 AT squared. And so X is equal to negative 1/2 AT squared for this problem. X is 100. T was 10. So A then is negative 20. And now that you know A, you can go back and find out what is V naught. You're not going to have to substitute. You're not going to have two equations with two unknowns, however. This one is actually pretty easy to solve. But I didn't lie to them. I didn't tell them that same statement. I probably warned them ahead of time, actually. I'm not lying to you. Okay? I told them a different thing than what I'm telling you. Okay, Crystal? Is that clear? All right, what else, y'all? Nagging items. Any questions about the format of the test? Okay. I understand y'all have organic. I understand that y'all have micro tomorrow. I'm sorry for that. I know that sucks. But that's life, right? Y'all have a great day, okay?